Okay, let's demonstrate this iteration process. Its iteration is actually the same. This place uses platform method local print, which is the sound command console, and there are two types of iteration here: a standard iterator and an array iterator. The standard iterator also requires read and write access to the front end, but this array iterator only allows access, right? We can get the value inside using kv. It seems like that's not right. This place might be. This sheet actually doesn't have k in y6 because our pointer directly points to its element. Yes, then let's just try it out. Then we'll just write it here. We use a loop. Okay, create it. We can just give it a number like this. Let's look at the first iteration method. Actually, the first method is a very common type of iteration. It iterates like this through automatic internal deduction, like O2. You can see it's O2. This element is FString. It is actually FS2T. Then here is the reference. We can investigate and make a change. We can do this. Let's add 1 to it. This way, it is convenient for us in the terminology, to make a simple distinction, proving that it is the first method. Perform an iteration. Pay attention to these references. So we can go modify it. After modifying it, we can then print it. Of course, if you don't want to modify it, you just want to copy it out, you can do this. Doing it this way is also fine, but we generally use references. Then you can add some to the front. Add some const, right? Of course, then you won't be able to modify it. There's nothing much to say about this. We will mainly take a look at this tiga. Actually, if you clearly know its type, you can write it like this. This way is also fine. Writing it this way is also fine. And if you add const, then you won't be able to modify it. It basically means this. Then we mainly look at the tiga device. As for the decals gun, it's still like this. This side is an auto. Okay, a decals gun was created at this location. The pointer for this decals gun now points to the first element. So you can directly print it here. Then we can actually retrieve it here and add a 3 to it. Let's take a quick look here. It seems like we aren't allowed to do that here, right? It's not allowed to do that here because it's a constant iterator. We can just remove this constant. That should be okay. Okay, and then we can then add another constant, or we can just skip the constant. Then let's add another constant. Okay. Let's just clean up the formatting a bit. Okay, this has a lot of nesting, right? If it's convenient. We should try to put the code on a single line. It has too many nested layers like this. We have a rule. You shouldn't nest too many layers of loops. You shouldn't put one loop inside another loop and then nest another loop. That is the literal meaning. It means in a general sense, don't nest too many layers. You just shouldn't write code like this. It's actually very hard to read this way because its context is unclear. Because you are not clear about the variables in this layer, whether these variables are used in this layer, and whether the variables of this layer are used by those variables. This will cause the hierarchical structure to be unclear. Okay, so this is a simple loop. Now let's look at its execution result. Okay, there are compilation errors here, right? Let's take a look. It seems like there's a slight issue. Let's find out what the problem is. It seems to be this. The problem here, it should be written like this. Yes, it should be written like this. Maybe you are a little confused. What is this? It should be written like this. Writing it this way is fine. Why should we write it this way? I'll explain it. Because you now, by going through a compile check, what do you get is stream. Then you need to convert it to tchar. You can then proceed. So you have to write it like this, but writing it like this before is okay. We should be fine with the audio composition now, because you don't have a way to. You need to convert this Apple strain into the tchar bar graph. So it's a situation like that. Okay, let's refine what's above. Actually, we can do it like this. Give it a quick pass along the bottom. It'll look better like this. Let's start testing it now. Okay, the prat has been hit on our side. After entering, we can see that we can add elements here. We pay close attention. We discovered when we outputted come out, the original one. This is our first method for simplification. For the second method, we directly write out the internal type. There are no problems with that. And then, because we simplified it to the same number, so this place is 1 and 2. As for the third one, we should add a 3. It does this through this carrier or by this method. Because when we print this area, we have something here, this one. It uses parentheses to frame the money, so there will be an extra parenthesis here. Then by printing the constant, we will print it once more. This number is also the same. So actually, at this point, this enters the combat within the blueprint. We don't need to worry about it anymore. Okay, so this proves that there's no problem here. And what you just saw is kind of blueprint combat. You don't need to worry about that at your current stage. It's just that in your method, we can set another breakpoint for everyone. Set another breakpoint for everyone. If we talk about it this way, let me elaborate on this a bit. Then we will restart this area. Actually, if you look, it actually runs before your function executes. This is your function. And where is the spot? Let's put this down for a moment. This is called setActor, specifically in C++. See, right? Then let's look at its call sequence. Actually, it enters here. You object call function. Here, this place is set up. It's the process of it entering step by step. You need a character ID to see it. So this is done by selecting it and then continuing into this spot. In where? Okay, in this spot. Let's take a look at these 4. These are the ones generated by our UHT. And these are the reflection files generated by UHT. After that, we will continue working further down and enter this method. Only then does it enter our function. Our method executes, 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 and then let it complete the cleanup. After the cleanup is done, let's see if we can continue moving down. Actually, we only care about this section. The execution of this method finishes here. Let's move further. And then it's at this point, it just pops out. Puts the in-work object farm here. This is something from the blueprint system. This gets quite deep. This is not what we need to understand right now. Actually, it has a system. And then you put something inside it. And then within this area, read it layer by layer. And then read the parameters passed out. Pass out these methods. And then wrap them up to execute our related code. Actually, all this code is part of the entire blueprint logic process. Okay, so let's stop here. Okay, then if we loop, you can actually do this through these 2 methods to perform a very simple iteration process.